Hello, this is my room temperature display project, and for one of my complexities, I am using USART to connect the transmitter microcontroller to the receiver microcontroller. And by pressing a button, the transmitter microcontroller should have sent a signal to the receiver microcontroller to trigger an LCD display. Unfortunately, I wasn't able to fully implement the user functionality. I was able, however, to make the receiver work. So I kindly ask you to look at my separate Complexity 3 video where I go into more details about how I compensated for that and how I made my USART work. And I did put a lot of work into USART trying to learn it, and I was able to make my receiver work. So I'm going to briefly go over the other pieces of hardware and software I used to compensate for that. So one of the pieces of hardware that I bought on Adafruit was the FTDI friend connector, which helps me which plays the part of the transmitter. And you can see the ground wire and the transmission wire, which connects, well, the ground connects to the ground on my receiver microcontroller, and the transmission wire connects to the receiver of USART 0. And for the software, I'm using MOBA Xterm to generate signal input. And again, I go over into much more detail into how I set it up, how many stop bits I used, what parity I used. But now I'm just going to show that the LED lights whenever I press a character on my keyboard. So now I'm pressing N on my keyboard and it lighted up. And now I'm going to show you that this part lights up. So you can see now I'm just pressing random characters on my keyboard and it lights up. This is another complexity, which is LM35, which measures the ambient temperature in the room. I set my threshold to be 21 degrees Celsius, and if the temperature is below that, as it is right now, you will see a little snowflake for the icon. And if it's above 21 degrees Celsius, you will see a plus for the icon. You can also view the temperature in Fahrenheit if that is more convenient for you by pressing this button right here. And you will see the 20 degrees Celsius converted to Fahrenheit correctly. And now I think I will switch back to Celsius because it's easier to operate in for me. And just to demonstrate everything, I will heat my LM35 with a regular blow dryer, so you will see the temperature go up and the icon change to a plus. Okay. Yeah, I heated up to 23 degrees Celsius and the icon did change to a plus. Now for the last complexity, I am implementing EEPROM, and there I am saving the highest and the lowest temperatures that were measured. So as you saw, the temperature oscillated between 20 and 21 degrees Celsius. And I was able to save that in EEPROM, and we can see this by pressing this button right here. Let's see, max 21, min 20 degrees Celsius. And for the second part of my complexity, I used this custom character for the degree symbol. And now, just to show how the temperature is saved, I'm again going to heat up my LM, and we expect the min to remain the same. So we expect min to be 20 degrees Celsius, and for max to keep the highest temperature, the highest temperature to which I will heat up the LM. Again, I'm using my blow dryer, and let's heat it up. Okay, oh, 51 degrees Celsius. Okay, and the icon changed to a plus, which is correct. And let's see what we have here. Max 21, or sorry, 51, yeah, and min remained 20. So that works correctly for both of my complexities, which is EEPROM, and the special character for the degree symbol, which again you saw right here.